Okay, so welcome everyone. Welcome back. A reminder that oh, what is it? Oh, so just a quick reminder that our next exam will be similar to the practice one that I posted. If you didn't get a chance to check it out, please check it out today. It'll be on kind of basic probability, conditional probability, Bayes' theorem, and binomial probability. And maybe a counting problem here, one or two counting problems, just to review from the last midterm. Um, and it'll be in class, and I'll just ask you to turn it in at the end of class. And if you can't make it, we can, you can just tell me what time. If Yeah, just let me know.
Will
But
that be
yeah,
on Thursday's class?
oh no, it'll be on next Tuesday's class.
Next Tuesday. Okay.
Yeah, so a week from. Uh, yeah, I'll make it on Tuesday. Um, so you have a few days to prepare, but hopefully you won't find anything too difficult on it. I think the most important thing is to be good at Bayes' theorem. Um, and Okay, so today what I want to go over is just basically prepare for this exam. So I want to go over anything questions that you guys might have had from the Bayes' theorem homework, because I know that there might have been some challenging questions towards the end, and as well just go over some of the questions from the practice test. And then on Thursday we'll start the new topic, which will be probability uh, probability distributions. Okay, so first, did you guys have any questions? First, does that sound reasonable, the test on Tuesday? And then second, do you guys have any questions on from the homework or from the practice test?
For the Mathopolis, the final three questions, I believe,
Yeah,
I I don't know, I felt like I don't know if you saw my note, but I said like especially on like 8 and 9 that I felt like I was essentially just copying down the answer and I wasn't able to grasp how to use Bayes' theorem for multiple outlets.
yeah, let's do those. I think those are really good. Let me
Okay.
just pull it up. Andrew, you said 8, 9, and 10? Okay, yeah, let's do all of those. Yeah, so I see a few people asked about them. Yeah, so I like to do Bayes' theorem with a tree diagram. There's other ways of doing it, but for me, the easiest way to remember this way I don't have to think about a formula, because I don't like formulas, as you guys know. I like to visualize things and so that they make more sense to me. So yeah, and the wording can be difficult as well. So let's do 8, 9, and 10 together. Uh, and I think if you can master those three questions and you followed what we did, you'll definitely be ready for the one on the practice test. So that'll be a great thing to do today. Okay, so let's try this out. Let me share my screen here. So, so today we're going to do another review of Bayes' homework. So this is number 8 from the Methopolis. So I'm just going to summarize the question. I'm going to drop the link in the chat so you can kind of try it out on your own. So I'm going to send it to everyone. So if you guys want to just pull this up on your chat, then you can do that here. Okay, so we see that wire is manufactured by a company. Wire manufactured by a company, it tested for strength. So wire is tested for strength. The test gives a correct positive result with probability of 0.85 when the wire is strong. So the test is correct, positive, when it's actually strong, with a probability of 0.85. Just really quickly, what type of probability is this 0.85? What do we call this type of probability? If you say this test is correct when it's a strong wire, the probability that it's going to be correct is 0.85. Nice, Angel. Angel says a conditional probability. That's exactly right. So if you ever say the probability of this happening when this happens, or given that this has happened, or you're in this sort of situation, that's called a conditional probability. So that tells us that this is kind of be along a second level of our tree, and we're going to probably multiply that by times something in the first level, which is the probability of it actually being strong. Okay, let's move on. But it gives an incorrect positive result. We get an incorrect positive result. This is a false positive with probability 0.04, with probability 0.04. And what's important to keep in mind with these conditional probabilities, 0.85, is that each time they give you something like this, they also give you the probability that a strong wire would test negative. There's always an implicit information that they don't actually tell you the number for. So you have to keep that in mind. And this is for when the wire is weak. So this is the wire is really weak. The wire is really weak. And one thing to keep in mind with Bayes' theorem is that we're always trying to figure out the true underlying state. We're testing something like, it's like a COVID test, right? They're testing if you have COVID, and the test might read out positive or negative, but the true state is whether the patient has a COVID or not. So this is the same idea. We're testing if the wire is strong, that's the true state, but the test is going to give us plus or minus. Okay, so now we say if 98% of the wires are strong, and a wire fails this test, what is the probability it is actually weak? So, so just looking at this test really quickly, this test will identify a weak wire with a 96% chance of accuracy. Right? If your wire is weak, the test will probably identify it correctly. But there's a kind of a pretty big problem here that if you guys do enough of these problems, that you can recognize that, the chance that it identifies a strong wire as being weak is actually pretty high. It's a 15% chance of identifying a strong wire as being weak. So if you look at the overall probability of strong to weak wires in the overall population of what they manufacture, most wires are strong. So if you were to look at kind of the population of wires that would get a score negative on this test, most of the negatives, I kind of just before doing the problem, will come from the strong wire. So given that you got a strong, a negative test, you can't actually, it's probably like not really guaranteed that the wire is actually weak. It's probably going to be 50-50. So let's do it carefully. What do you guys think? Anyone want to volunteer what the first branch kind of should read out?
The First branches should read out strong and weak.
Excellent. Nice. So strong and weak. And we have 0.98 and 0.02. These are the true states. So the true states that we're looking for are always the first branches. Now is the test. So if you're strong, what was the probability that it will be identify you as give you a positive result? That's 0.85 positive. And if it's weak, or give you a negative with the remaining percent, 0.15. And remember, you're going to have to multiply through here to get the overall probability of that branch. And the same thing over here. If it's a weak, we do positive and negative. And what's the probability that we get it? The test is mistaken and says, oh, you actually have a strong wire, but in reality, the true state is weak. What percent should I put for the positive? For the positive one, it should be 0.04. It should be this one. But that would be incorrect. But for the negative test, which would be the correct result, the true negative, would be this one. Okay. Any questions so far about anything about the wording? And by the way, I think I really like Bayes' theorem. Somehow YouTube was feeding me like this philosopher, this lady who does like philosophy, and she was talking a lot about Bayes' theorem. So maybe I'll share some of the videos about kind of how Bayes' theorem is important when you're trying to think about your biases and stuff like that. That's very very interesting. So yeah, I'm happy to go over any step of this. Do you guys feel thumbs up if you feel good? Any thumbs down if you feel not so good? All right, cool. And by the way, I have let me put you guys on. All right, great, sweet. So now that we've got the tree set up, and you see, like once you get the pattern of doing these, setting up the tree shouldn't take too long. Now we can actually solve the problem. What is the probability if you get a negative result that it is actually weak? So when you do this on the test, please, I would like to see you actually use the notation. So I'm gonna hope that you write, what's the probability of being weak given that you got a negative test? Well, the denominator is the universe that we're in. So the number or the percentage of all negative results. And the numerator will be out of those negative results, which ones corresponded to actually weak wires. So the answer would be, let me do it in highlighted here. So all the negative tests would be all the negative branches. So this branch and this branch. And the numerator is just going to be the weak branch. Okay, so I'm just going to put the numbers in. 0.02 times 0.96 divided by 0.02 times 0.96 plus 0.98 times 0.15. Well, the next test will be on next Tuesday.
Do you have to rewrite the negative branch, or can you just put the because it cancels out, right?
Nothing. Where would you hit the canceling? I'm not sure.
The 0.02 times 0.96 would cancel from top to bottom, and it would become 1 over 0.98.
Oh, okay, good. Very good. No. So it doesn't quite cancel. You're thinking more. So when you have a fraction like, let's say, 2 over 2 plus 5, right? This part, these won't cancel. This is just 2 sevenths. So you can't cancel that way. What you could do is you could, if you did 2 plus 5 over 2, if you look at the reciprocal, you're right, you can distribute over that. You can do, this would be 1 plus 5 halves. Because the one half kind of like is more.
Oh,
like,
okay.
yeah, be careful. I've seen that mistake a few times. So yeah, you can't cancel. You can't divide like that. But if you saw if there was a common factor that you can cancel out for sure. Like if there was a 0.02 here and a 0.02 here, then you can do that for sure. You can cancel off. Oh. Yes, Angel, I see it. I think I might have announced. I actually don't remember that when I said the last test would be. But let's just do it next Tuesday on Thursday. I'll start the new section. So today will be kind of a review day, and also this way on Thursday, if you have any other questions from the practice test, we can go over them as well. I just want to give you guys a little extra time to prepare. I know coming back from break, I don't know. This is time to relearn some of this stuff as well. But yeah, sorry for the confusion. Okay, so a good question here. Why do I multiply 0.98 times 0.15? Right. So the way to think about this is 98% of the wires are strong, but 15% of those strong ones will get you a negative test. Will test negative. So to get the number of wires that you will actually test negative but are strong, you multiply 98.98 times 0.15. That's 15% of the 98 strong wires. That would represent this number. So these are and the denominator overall is like if you took all, let's say there's 100 wires, and you applied, 98 of them are strong and 2 of them are weak, and we applied the test, this like whatever machine that they're using, to all 100 wires, the denominator would represent how many of those wires overall tested negative. So these are the wires that tested negative but were actually strong, and these are the wires that tested negative but were actually weak. Okay, let's try the next question, number 9. So, hang on, I didn't finish this. Let me just, does anyone see what the answer is for number 8? Let's see. The answer is C, which is 0.12. So just calculating this. 0.12, which is really low, So that's a really low percentage. Let me go to number 9. Let's try this one together. So the supermarket buys light bulbs from 3 different manufacturers. So now there's going to be a bright light, which is 30. We have bright light, which is 35%. Glow, By the way, have any of you guys heard of this company called Aptera? It's a new company based in San Diego, actually. They're making this crazy car. I'll share a link also. It's an electric car that you never need to charge. It can be powered off of the sun, and it's like an airplane almost. Yeah. It's a very small. It's like a two-seater. But the reason I thought of it is that like in the front they have something called like a logo or something. Oh, they have it at UTC, really? Oh, I haven't seen it in person. That's really cool. Where in UTC is it?
I don't know, but they have like a car outside and you can go and sit in it, I think.
Really?
It's really cool. I gotta see it, yeah.
Is it so? Is that the mall?
Yeah.
Oh, okay, awesome. I want to go check that out. Yeah, I saw it. I was blown away. I thought the video looks so cool. And I saw them like riding along like in Gaslamp. I was like, oh wow. And they're based in San Diego. Okay. So anyhow, there's three light globe companies, and the supermarket. I guess they're all identical. They all look pretty much the same. But the supermarket found that 1% of bright light globes are faulty, and 1.5% of each of globe and Shinewell globes are faulty. So a customer picks a globe at random, and finds out that it is faulty. The question is, what is the probability it is a Shinewell globe? So are there any questions about the setup? And just out of curiosity, how many of you got to do this for the homework and understood the solution and were able to get the solution? Nice, cool. Nice, a bunch of students. Yeah, but less than half. Very good. But I'm glad that you guys figured it out. That's awesome. And I think I'll maybe for the exam on Tuesday for extra credit, I think I'll do one that's one base problem that's a little bit more involved, like this one, because this one has a little bit harder than the last one. Okay. So what is the true state here that we're trying to figure out? What's the unknown thing that we're trying to? Yeah, number 10 has 4. That's a little bit intense, maybe. What's the true state that we want to know? If this customer bought a globe, they can see if it's faulty or not, but what don't they know that they're curious to find out, or might be curious to find out?
Who made the globe?
Exactly. Nice, Andy. Yeah, they don't know the true state that's hidden from us is the manufacturer. I mean, technically, maybe you could like you know, unscrew it and look at the uh, uh, name. But in this problem, let's say for some reason there's nothing labeled. We don't know what the manufacturer name is. So the true state is the who made the globe. So that means we're going to have three possible true states this time: bright, low globe, and shiny. So I'm just going to do B, G, and S. So B, G, and S. And I'll write the probabilities here: 0.35, 0.2, and 0.45. And then for each of these manufacturers, we're given a conditional probability that the probability of the globe is faulty from each manufacturer. So we know that it's 1% that it's faulty, and not faulty. So it's 0.01 and then 0.99. But for globe and Shinewell, it's 0.015 and 0.985. Being careful with faulty, not faulty, and the same thing here. 0.015 and 0.985. Faulty and not. So this is our tree. And which probability are we trying to find? We are trying to find the probability of, yeah, I might have to go after this problem because it depends how my daughter is acting. My wife had to go. So, yes, so we need to find the probability that the globe is from Shinewell, given that it's faulty. So our denominator is going to be all faulty globes. So it's going to be this one, this branch, and this branch. And our numerator is going to be, out of all those faulty globes, which of those came from Shinewell? So it's just going to be this globe. So I'll write it all out. It's going to be 0.45 times 0.1015. And the denominator is 0.35 times 0.01 plus 0.2 times 0.015 plus 0.45 times 0.015. And I would recommend doing kind of the numerator and denominator separately so that you don't make mistakes with parentheses, and kind of maybe calculate these numbers carefully in the calculator. And then the final answer, if you do this all out, the final answer comes out to about 50%, 0.5 million. And if you're looking at these answers, that's not super surprising, because you can see that basically the probabilities are quite similar for having a faulty globe. So the weighting, most of the faulty globes would just come from the one that's from the highest, the one that's made most often. Are there any questions on this problem? Oh, Dimitri, this is Bayes' theorem.
No, I mean using specifically the numbers, the equation.
Oh, using the equation.
Is it even possible to do that?
Yes, yes, yes. So the thing with the equation is, let me think about how to write this here. They have it in the solution written up. So I'll write it out because and this is you'll see kind of why I don't like the equation. But so probability that Shinewell, given that it's faulty, is equal to it's actually not too bad to write it. So it's equal to the probability of faulty, and then the numerator is probability of Shinewell and faulty. So far this is not Bayes' theorem. This is just conditional, the definition of conditional probability. But we can break it up into Bayes' theorem Bayes' theorem really comes out by rewriting these steps using conditional probabilities. So anytime you have an intersection, you can actually write an intersection of two things happening as a product of a conditional probability and the other probability. Meaning that anytime you're thinking about two things happening, you're really talking about walking down a branch. So what I mean by that is the numerator is really probability of being Shinewell times probability of faulty given that you're Shinewell. This is also, this substitution is also comes from what do you call it? Just the definition of conditional probability. Then the denominator part is interesting. It's all faulty. It's all faulty light bulbs, but we know how to get all faulty light bulbs. All faulty light bulbs have to either come from, because we've divided our universe into 3 different types of light bulbs. All faulty light bulbs are either one of 3 types. So the denominator is probability of faulty and Shinewell plus probability of faulty and glow globe.
And then you could break this down even further into basically what's on the numerator, right?
Exactly.
Neat.
So and that gives you the formula that I've always personally found like impossible to memorize because like switching things like this is but yeah, that's where it all comes from. And it's not too hard to remember where it comes from. It really comes from the idea of the definition of conditional probability. Then the tricky part is breaking up the numerator as another conditional probability, because thinking about like going along the branch. And the trickiest part is the denominator doing this sneaky thing where probability of the faulty light bulbs come from each manufacturer. And then breaking up those exactly like you said. What was the last thing? Shinewell and Brighter. So very, very good question, and I'm glad I got to show that to you. But if that confused you, please don't worry about it. Only focus on what's most important is that you understand the tree and why it works. Any questions? Let me take a look at number 10. Okay, so how about this? Number 10 is a same type of thing. It's about somebody buying glasses from different manufacturers, but sometimes the glasses can be cracked. And the person finds that the glasses are cracked and they want to figure out what manufacturer they come from. So the process is almost the same. It's a great one to practice if you haven't done it yet. Just a quick show of hands. How many of you got to do number 10 and it made sense? Okay, awesome. Those of you that didn't get to do number 10, do you think you can try it? Even if you turned in the homework already, I saw a lot of people turned it in, I returned it already. Please check it out. Do you guys want to just check that out for homework if you haven't done it yet? I think it's a really good one to practice, just the setup if you followed along with 8 and 9. Okay. Guys, I'm sorry. I think I might have to end class early today. Bring her up here. But before I end class, I can ask if anyone had any questions on the practice test. But I'll be right back in a second. We'll have a new guest. All right, guys, this is Samantha. If you guys can see her. Do you guys have any questions on the, thank you. Do you guys have any questions on the practice? Have another, okay, yeah. Take a look over the practice. If you guys have any questions, we can definitely go over it on Thursday. Yeah, she's starting to get her teeth coming in, so she's been a little bit grumpy. But she likes all the monitors. Let me see here, classwork. The practice test 2, probability. So I'm just looking up the first few questions here. Question 1, that's a good one. I can post the answer so you guys can. Yeah, I'll post an answer key later tonight, so you guys can check your work. Question 1 should be really straightforward. And again, we can go over any of these if you guys want. Number 2, so we did some of these similar ones in class. And number 5 is kind of like the ones that we just worked on. Number 6, 7, and 8, I don't think I'll have all 3 of those, maybe not even any of them, because those are, this was from a previous class where I don't think I got to do like test 1. Don't expect to have all 3 of them for sure. But maybe something more like number 4, or something like the shaft problem that we did. That could, I might ask something like that. Oh yes, the challenge question is totally optional. That was from the challenge homework question. Yeah, just looking over this, do you guys have anything that you wanted to go over or ask about? Okay, so yeah, tonight would be great if you look over the, okay, yeah, if you haven't had a chance, okay, great. So yeah, I'll post the answer key so you guys can take a look at your work tonight. And then on Thursday, if you have any questions, we can go over this. And then I've also posted the next lecture, Thursday lecture ahead of time, so you can check that out if you want before class. It's really simple. We're going to discuss an intro to what we call probability distribution and like histograms, which I think many of you have seen histograms before as well. All right, guys. I will see you on Thursday if there's no other questions. And finish off. Will the test have any questions from Thursday's lecture? No, the test will not. The test will be everything we've covered up to today would be on the test, but nothing from Thursday's lecture, except whatever we practice.
Thank you.
Okay, see you. Bye, guys.
Thank you. See you
Bye.
Thursday.
Thank you.
See you on Thursday.
Hey, Thursday.
Take care, guys.